Bismillahirrahmanirrahim. Dear students, today lecture is 46, grade 11, and we are talking about chapter number 6. And the topic is isomorphism. Isomorphism and polymorphism, solid state. Isomorphism and polymorphism. Solid state, grade 11, lecture number 46, number 8 and 9. Iso means same, morphous means parts. The substances which have different substances which have a similar shape, two different substances which have a similar crystalline shape are called isomorphism. Isomorphous, different crystalline substances having the same crystalline shapes are called isomorphous, and the phenomena is called isomorphism. So we have two compounds isomorphism, zinc sulfate and nickel sulfate. These two different compounds, atomic ratio is 1:1:4. They have the same atomic ratio and they are isomorphous because they have a same crystalline form. That's called rhombohedral. Both have the rhombohedral. Silver sulfate and sodium sulfate, ratio 2:1:4. These two, silver sulfate and sodium sulfate, ratio 2:1:4, they have a hexagonal. Calcium carbonate and sodium nitrate, ratio is 1:1:3. So they have also zinc sulfate or orthorhombic hexagonal and rhombohedral. These are the isomorphous. Two different crystalline substances having the same crystalline form. Two are orthorhombic. These two hexagonal. These two are called rhombohedral. Polymorphism. Poly means many. Morphous means parts. Single substance. Single crystalline compound which has more than one crystalline structures are called polymorphism. The phenomenon is called polymorphism. Sodium chloride is one compound which has two crystalline forms. One is called cubic and other is called octahedral. cubic and octahedral. So these are called polymorphous. Calcium carbonate. Calcium carbonate has a two, which is called, one is trigonal calcite, and the other is called orthorhombic aragonite. Trigonal when the present as calcite, orthorhombic when the present as aragonite. So these are the substances, and also mercuric iodide. This mercuric iodide has orthorhombic in the yellow form, and tetragonal is in the red form. So single compound, not an element. Single compound which has more than one crystalline structures are called polymorphous, and the phenomena is called polymorphism. So there is a difference between the polymorphism and allotropy. In an allotropy, substance which should be in the elemental form, which is in the elemental form. One element, sulfur, carbon, phosphorus, silicon. Sulfur, carbon, one element has more than one crystalline form: carbon, diamond, and graphite. Allotropes. Allotrope is a Greek word. Allos, other, tropia, turning. When one form turns into another. When one form turns into another is called allotropy. Greek, allos, other, tropia, turning, forms. An element may exist in different crystalline form. Element, carbon, diamond, and carbon is in the graphite. So diamond is in the cubic form, graphite is in the hexagonal form. Then there is another one we call transition temperature. Transition temperature, the temperature at which more than one form given substances can exist in equilibrium is called transition temperature. The temperature at which more than one forms of given substances can exist in equilibrium is called transition temperature. That's like tin. Tin gray and tin white. These both forms of tin coexist. This is the orthorhombic. And this is a tetragonal. They are going to exist both at 18 degrees Celsius. 18 degrees Celsius is a transition temperature for both at equilibrium. So when you increase the temperature or decrease, there will be a change. But if you maintain the same temperature, these two crystalline forms coexist. Sulfur, monoclinic. Sulfur, orthorhombic. Sulfur, monoclinic. Sulfur, orthorhombic. 95.6 degrees Celsius is the transition temperature for the sulfur orthorhombic and monoclinic. So at this temperature, both these crystalline forms of sulfur coexist. Potassium nitrate, orthorhombic and rhombohedral, 128.5 degrees Celsius. So dear students, if you done all properties of the solids, crystalline solids, allotropy I told you, an element makes different crystalline forms, just like carbon and sulfur, maybe phosphorus. Oxygen has two allotropic forms. One is called oxygen O2 and another is called ozone, O3. Ozone is a gas which is present about 22 to 24 kilometers above the Earth's surface in the stratosphere, and it acts as a filter. It filters all ultraviolet rays coming from the sun. They are highly dangerous for the living organisms. So oxygen changes into ozone, and ozone changes into oxygen naturally in the stratosphere. And when oxygen gas changes into ozone, 142 kilojoules per mole amount of energy is required. Certain amount of heat is absorbed. I told you oxygen dioxygen into trioxygen. Ultraviolet rays is coming from the sun, and they are going to hit the ozone gas. This ozone gas changes into oxygen gas and atomic oxygen. This is a natural phenomenon. Ozone gas is present in the stratosphere. So when the ultraviolet rays directly coming from the sun strike the ozone layer, ozone changes into oxygen gas and nascent oxygen, atomic oxygen. So this ozone gas is going to be depleted, but at the same time, this oxygen gas and nascent oxygen, atomic oxygen combine together again to formation of ozone. That's why there is a spontaneous process. So there is a no destruction of ozone from the nature. And this concentration is about 10 parts per million, ppm, parts per million. About 20 to 30 kilometers, 24 to 30 kilometers above the surface of the earth, ozone layer is present. Ozone has structure like this one. This is the center oxygen. It has a angular shape, V shape. And negative charge is here, negative charge is here, positive charge is here, and the distance between this oxygen and this oxygen is a 1.278 angstrom, and the angle is 116.8 degree. So oxygen has a double covalent bond, one sigma bond and one pi bond, and 117 degree angle is there. The ozone layer is the atmosphere which acts as which is filter and also decrease the intensity of the ultraviolet rays. Sulfur, there are 4 allotropes: rhombic sulfur, monoclinic sulfur, amorphous sulfur and plastic sulfur. Rhombic sulfur is also called which is yellow in color and stable at 96 degrees Celsius, and there are S8 atoms. 8 atoms. Monoclinic beta sulfur, crystalline solid, stable between 96 degrees Celsius to 119 degrees Celsius. It's converted into roaming sulfur at room temperature. Amorphous sulfur, which is called sigma sulfur, it has a irregular crystalline shape, which may be called amorphous. It is not found in the free state. It may be prepared by passing hydrogen sulfide gas through water. Hydrogen sulfide gas through water, you can see the chemical reaction. It forms oxygen gas is going to be passed to form a water and also amorphous solid sulfur. Plastic sulfur. It is supercooled when you are going to heat normal sulfur in a test tube at very high temperature. So it is going to be changed into liquid form. So if you heat more, this is a red, then more heating, it is going to be blackish and turns to volatile, and fumes are coming out. When you put suddenly in the cold water, so it changes into a plastic sulfur, and this is going to be dissolved in carbon disulfide, not hydrogen sulfide. CS2, it is soluble in the carbon disulfide, but plastic sulfur is not going to be dissolved. Then students, very important topic is called crystal lattice. Crystal lattice. The regular arrangement of particles of crystalline solid at microscopic level produces characteristic shape of the crystals. In the crystalline solids, the position of the particle is fixed. They are represented by the lattice points, area of points, lattice points. These area of points are lattice points. They show position of the ions, position of atoms, position of the molecules. They are in three-dimensional because we are talking about crystalline solids. So when the external shape of crystalline, depending upon condition of crystallization, it may be different from one another. Just like pure sodium chloride is cubic in nature, but if you are going to place impurity, urea, 10% urea, then it may be different crystalline structure. It is going to be changed into maybe hexagonal. So this unit describes the pattern by which the particles are arranged in a crystal. So there are three: shape of unit cell, contents of the unit cell. The atom molecules are ions present in the crystal lattice, repeated in a system manner. So dear students, definition of crystal lattice is the smallest unit of the crystal. Smallest unit of the crystal, of volume of the crystal, which shows all properties of its pattern, is called unit cell. So smallest unit, if we take, which represent the whole crystalline system, is called a crystal lattice. This is the basic structural unit of crystal. The systematic arrangement of atoms in crystals are called lattice. It represents the structure of any substance. So dear students, there are three types: three-dimensional lattice, two-dimensional lattice, one-dimensional lattice. Three-dimensional, two-dimensional, and one-dimensional. Now, unit cell are shape of sodium chloride. Unit cell. Shape of sodium chloride crystal. So, when we explain the significance of unit cell into the shape of sodium chloride crystalline form, so you can see like this. These are the area of points. They show cations and anions. So suppose this is the sodium ion and this is the chloride ion. Sodium ions are smaller than chloride ions. Sodium ions. Chloride ions, larger size. Sodium ions. Chloride ions, like this. And here, sodium ions. This is the 1 unit of sodium chloride. This 1 unit contains four we can say formula units. Sodium chloride, sodium chloride, sodium chloride, sodium chloride. There are four. There are four formula unit present in one. So these are the area of points. Lattice points are area of points in the 1 unit of sodium chloride. We have to also prove that there are 4 formula units of sodium chloride present in 1 unit cell. The unit cell is primarily concerned with the shape of crystalline substance. Keeping in view the shape that crystal structure can be identified, let us take example of sodium chloride I told you. These are the location of the ions. Ions are located. The point number 1 is called location of the ions. Location of the ions. So, sodium chloride has 2 ions, positive sodium and chloride. So in the crystal system, 6 chloride ions are surrounded to 1 sodium ion and 1 chloride ion is surrounded by 6 sodium ions. The size of chloride I told you bigger, larger than that of sodium ion because sodium loses 1 electron, so only 10 electrons, 1 shell is lost, removed. Chloride has 7 electrons, 1 is added, so 3 shells. So chloride ion is bigger than that of the sodium ions. Coordination number same. The number of ions surrounded towards the central ion is called coordination number. So sodium has a 6 coordination number and chloride is also 6 because each 6 chloride ions are surrounded towards sodium and 6 sodium ions are surrounded towards the chloride. This is called coordination number. Number of sodium chloride in unit cell, already I told you. These are the four number of sodium chloride are in 1 unit cell, and I told you the answer is 4. There are 4. So we have to calculate Sodium chloride, there are 8 chloride ions at each corner. 8 chloride ions are at each corner of the cube. Each chloride ion is shared among 8 unit cells. Each phase shares with the 2 unit cells. So the number of chloride ions in each unit cell can be calculated by using this number A. Calculation of chloride ions. Number of unit cell 8. Number of chloride ions are 8. So number of chloride ions in one unit cell 8 over 8 you will get 1. Total number of chloride ions at a regular octahedron 6. The number of unit cell containing phase 2. So number of chloride ions 6 over 2 is equal to 3. 3 plus 1. 3 plus 1 is equal to 4. So there are 4 chloride ions present in one unit cell. You are seeing 4 both. So there are 4 total. Calculation of sodium ions. Sodium ions present at the edges. Number of edges present in cube 12. Number of unit cell sodium ions are 4. Number of sodium ions present in each edge 12 over 4 is equal to 3 sodium ions. Sodium ions present in the center is equal to 1 sodium ion. Total number of sodium ions is equal to 3 plus 1 is equal to 4 sodium ions. So each sodium cell consists of 4 sodium ions. So it means that in one unit cell there are 4 sodium ions and 4 chloride ions. So that's why 4 formula units of sodium chloride are present in one unit cell. So dear students, we are going to stop here. So inshallah, one topic is remain behind. So we will complete this chapter in the next lecture inshallah. So thank you very much.